Hey everyone, in this short video, I'll show you how to use Desmos to do some matrix calculations. But first, let's go to the website. As you know, this is one of my favorite online calculator that I've been using for a while. So if you go to desmo.com, if you just want to use the graphing calculator, you can click here. But if you want to work with matrices, you want to click on the map tools and go down to matrix calculator. And I usually use the reverse contrast with the graphic mode. All right. So now let's look at our problem. The problem gives you a system of equations. So the system has 3 variables, x, y, z, and 3 equations. And then the question asks us to find the coefficient matrix, and we call it A as a coefficient matrix. All right. So just go to here. You want to click on the new matrix. A, you should start with A. And because we have 3 variables and 3 rows, that means the matrix, the coefficient matrix has to have 3 rows and 3 columns. Remember, each of the column represents for each of the variable. Okay, and then we just enter the coefficients of each of the variable in each of the equation. So you have 2 here, -1, and 0 because there's no z, 1, 2, and 1, and 2, 1, 1. All right, here's we have the coefficient matrix of this system of equations. And the next question is to ask us to find the reduced row echelon form of A. So in Desmos, you can, once you create a matrix A, you can click enter, and then if you look at this panel here, there are some matrix functions in which you can use. The one that we want to use is this one, REF. So REF functions, and you can just enter A in it. And on the right side here, you will find the reduced row echelon form of A. In this case, is an identity matrix. Okay. All right, so, and we learned something about a square matrix whose reduced row echelon form is an identity matrix. Guess what? A is a non-singular matrix. All right, the next step is solve for x, y, and z. So if you look at the reduced row echelon form of A, you can read the solutions of this system using the reduced row echelon form of A. And more particularly, you can see that since all the value on the right side of all the equations here are zeros, which means the constant vector of this system is 0. So then this is a homogeneous system. And since it's a homogeneous system, then I can answer the questions. I can find the solution of x, y, z to be x equals to 0, y equals to 0, and z equals to 0. Okay. Another way that we can find the solution for x, y, z is we can come up with the Amentic matrix of the system of equations. So I call the Amentic matrix to be, let's say we can do this, G as an Amentic matrix of the system. And G, which Amentic matrix is a matrix that start with the coefficient matrix, and then you enter the constant vector, which is the constant, the values on the right side of the equations, as the next columns. So that means we need to have 3 rows, as we have 3 equations. We need to have at least 3 columns for the 3 variables, and adding another column for the constant vector on the right side of the equation. All right, so for the first 3 rows and columns, I'm just going to enter the coefficient matrix, -1, 0, 1, 2, 1, and 2, 1, 1. And then the constant column in this case it's just 0, 0, 0 because you have 0, 0, 0 here on the right side of the equations. And the next thing is you can find the reduced row echelon form of G. And that will give you the idea of what the solutions of the system is. So if you read this reduced row echelon form, you say that 1x equal to 0, 1y equal to 0, and 1z equals 0. That means, x, y, z equals to 0 is a solution. All right, I can write it down here. So the solutions is 0, 0, 0. Okay, for x, y, and z. All right. Now, the next question asks us to explain the procedure of finding the inverse matrix of a non-singular matrix. So, as we talked earlier, since the reduced row echelon form of A is an identity matrix, which means A is non-singular, and we can find the inverse of A. And the definition of the procedure of finding the inverse of A is you are coming up with a new matrix that contains A on the left side and the identity matrix on the right side. Okay. Let's go down here. I would set, let's say, C equals to a new matrix. So the matrix A has 3 rows and 3 columns, and the identity matrix has also 3 rows and 3 columns, and then that means we have 6 columns. Okay, so the first 3 rows and 3 columns, I will just entering the matrix A, which is the coefficient matrix of A, right, of the system, 2, 1, 1. And on the last 3 columns, I will enter the identity matrix. And now, as you know that once we construct this matrix, we can just find the reduced echelon form of this matrix. And on the right side here, you can see that the first 3 rows and columns will give you the identity matrix, and the last 3 rows and 3 columns will give you the inverse of matrix A. If A is invertible, A is non-singular, then this procedure can be done, and you can find the inverse of A's using this procedure. All right, and using Desmos, you can find the inverse of A using the functions, the A inverse functions down here. So you start with A, and you click on the inverse. You can see this. You can just compute the inverse of A. 1, 1, -1, 1, 2, -2, -3, -4, and 5, which is exactly the same as the matrix that we found earlier. All right. So we found the inverse of A, which is a part of the next question using a calculator, which we did. And then we solve the equations AX equals to B, where B is this vector. All right. So let's talk about how can you solve these equations. Now B is not a 0 vector anymore. B is a non-zero vector, which is given here. So in order to solve for these equations, we know that A is invertible, A inverse exists. That means we can just multiply A inverse to both sides, to the left of both sides of the equation. And since A inverse times A equals to just the identity matrix, then you can simplify the left side to be Ix equals to A inverse of B. And I is an identity matrix. You can consider as a 1, so you can just ignore it, which means X equals to A inverse of A inverse times B should be your solution. So in order to find the solution, solve for the equation, you need to take the A inverse and multiply by B, the vector B, the constant vector on the other side of the equation. So in order to do that, so that we have the inverse of A already, but now we need to find B. So B equals to the new matrix, and you see that it has 3 rows and only 1 column, and 1, -2, and 1. Okay, and the solution X will be equals to A inverse, and you multiply by B. All right. Here is your solutions. So the solution XYZ will be equals to -2 as a value of X, -5 as a value of Y, and a 10 is a value of Z. So this is X, this is Y, and this is Z. All right, so I just demonstrated how you can use Desmos in order to do some matrix calculations, matrix and matrix functions, including creating matrices, finding the reduced echelon form, finding the inverse matrix. That's the 2 functions that we have here, right? And there's more functions that you can use. For example, you can find the square of A, the matrix A, square of the matrix A, and then you can also, let me erase this, the square of A, and you can find the transpose of A transpose, okay? Swap the rows and columns. You can find the determinants of A. Because A is because A is a square matrix, so you can find the determinant of A. And the determinant is 1, which is not 0, so that's why A is non-singular. You can find the trace of A, and by the definition, the trace of A is the sum of all the diagonal entries of A. In this case, it's 5. The trace of A is 5, and then you can roll up to the matrix A here, and you can see that the sum of 2 plus 1 is 5. So by the definitions, the trace of A is a sum of diagonal matrix of A. All right. Well, I hope that you learned something new today, and now that you are confident in using Desmos in order to do some matrix operations, matrix calculations, you don't have to use fancy calculation. This is free online. You have to pay for the internet, but other than that, you don't have to pay for like a fancy calculator in order to calculate some of the matrix operations. All right. I hope you guys have fun.